We tend to view the city as a monument to human will, a relentless engineered organism that demands constant maintenance and control. It is a system built on routine, the daily sweep of a broom, the scheduled repair of a pipe, the predictable flow of traffic. Our presence, for all its complexity, requires an enormous expenditure of energy simply to keep the edges neat, the structures intact, and the wilderness at bay. But what happens when that constant effort falters? When the rhythm breaks, we are accustomed to the noise, the movement, the sheer density of human activity. Yet there's a profound silence in these abandoned arteries of commerce. It is not merely an absence of people. It is the sudden dramatic withdrawal of maintenance, the cessation of routine care that has defined our modern lives for so long. And when that curtain of constant vigilance finally drops, something else begins to stir. Something ancient, patient, and utterly persistent. Look closely at the cracked asphalt, the crumbling facade. Here, where human hands once dominated, seeds find purchase in the dust. The first pioneers are not machines but tenacious roots, initiating a slow, verdant reclamation of concrete and steel. The initial colonization is perhaps the most subtle, yet fundamentally profound. Before anything visible, before saplings or flowering weeds appear, the substrate must be prepared. Life begins in the microfractures, the hairline cracks in mortar, the porous surface of weathered concrete. These tiny fissures provide not only a foothold but also a unique reservoir for moisture and trapped organic detritus. Here, specialized pioneer species take hold. We are talking about lichens, which chemically etch into rock surfaces, tenacious mosses that trap humidity within their spongy structures, and minute cyanobacteria films. They are the first biological agents to break down the artificial environment, initiating what ecologists call primary succession on an unnatural medium. This foundational work is slow, almost imperceptible, yet it fundamentally alters the chemistry of the surface, making way for the next wave of life. These early colonizers are masters of adaptation. They thrive on minimal nutrients, drawing sustenance from airborne dust and mineral runoff. Their cumulative action, the slow release of acids and the physical wedging of roots, is what transforms inert stone into a viable, living substrate. The city is slowly being reclaimed, one microscopic foothold at a time. The initial colonization, while crucial, only scratches the surface of nature's tenacity. Next comes the vascular invasion, the emergence of larger, more ambitious life forms. These are not mere weeds. They are pioneer species, saplings and woody undergrowth whose roots possess an astonishing capacity for exploitation. They do not wait for structural failure. They actively seek out the inherent weaknesses within concrete and masonry. Ailanthus, certain tenacious trees, or fast-growing shrubs find purchase in hairline cracks, expanding their root systems with relentless hydraulic force. Over time, this biological expansion exerts immense physical pressure, a slow, inexorable prying action that exceeds the compressive strength of even robust architectural materials. What began as a minor fissure becomes a widening fracture, demonstrating how life's most fundamental processes can become powerful agents of deconstruction. The architecture is not merely being weathered, it is being dismantled from within by biological engineering. This process is visible in foundations lifted by decades of root expansion, transforming stable structures into precarious ruins. The sheer volume of biomass accumulating underground fundamentally alters load-bearing capacity, ensuring that nature's reclamation is a slow, structural inevitability. The ecological takeover does not stop at the roots and vines. As the plant life reclaims the structures, so too do the animals. The abandoned city center transforms from human monument into wildlife preserve, a predictable haven away from the unpredictable intensity of modern development. These ruins offer a unique blend of resources: shelter within crumbling foundations, reliable hunting grounds in overgrown plazas, and water sources that remain accessible. Species ranging from adaptable raccoons to opportunistic foxes have found these forgotten urban canyons ideal for establishing new territories. Birds utilize the high ledges and broken windowsills as nesting sites, while rodents exploit the structural gaps and subterranean networks left by decay. These animals are not merely passing through, they are integrating into the ecosystem, utilizing human waste streams and natural decay alike to sustain complex life cycles. The city's ghosts thus become a vibrant, if unsung, habitat for resilient fauna. Even apex predators like stray cats and coyotes navigate these forgotten corridors. Their presence maintains a delicate balance, keeping populations in check. This natural regulation completes the cycle of life within the concrete shell. The true foundation of this resurgence, however, lies beneath our feet in the soil itself. At first glance, these ruins appear sterile, yet a profound process of biological alchemy is underway. Organic debris, everything from fallen leaves and shattered wood to accumulated dust, begins its slow descent into decomposition. This decay is not merely waste, it is raw material for life. Microbes, fungi, and countless unseen organisms break down complex compounds, releasing essential nutrients that were previously locked away. Over time, this gradual accumulation forms humus, the rich, dark substrate that defines viable soil. It is the critical tipping point. Once a sufficient layer of nutrient-rich earth exists, the potential for plant life explodes. The ground can support increasingly diverse and structurally complex flora, allowing the entire ecological tapestry to deepen its roots into the very heart of the concrete jungle. This newly formed substrate acts as an anchor for pioneer species, allowing deep taproots to penetrate what was once impermeable pavement. These foundational plants stabilize the structure while simultaneously enriching the soil further, initiating a self-sustaining cycle of life and decay. The pace of this rebirth is not uniform, it follows a measurable gradient. By studying these abandoned sites, we are observing secondary succession in real time, a powerful demonstration of nature's relentless ability to reclaim its space. Some locations remain dominated by opportunistic weeds and fast-growing pioneer species, barely concealing the original concrete skeleton beneath. These early stages show life clinging fiercely to minimal resources. But move further along the timeline, and the evidence shifts dramatically. Here the canopy closure is nearly complete. Saplings now reaching for sunlight form a dense understory that filters the light into dappled emerald pools on the forest floor. The initial pioneer species give way to more complex woody growth, suggesting the eventual emergence of entirely different biomass within the urban shell. It is a slow, persistent process, a testament to ecological resilience, where the ruins become not just shelter for new life but the very foundation of a novel ecosystem. Over decades, these microclimates stabilize, allowing climax species to take root in the accumulated detritus. The urban jungle thus completes its cycle, transforming decay into a self-sustaining, verdant monument. The resulting landscape is undeniably wild, yet this assumption requires careful scrutiny. What we are observing might not be nature reclaiming itself from human error. Rather, it could be a highly managed form of decay, a process shaped by the very infrastructure humans left behind. The remaining concrete, glass, and steel act as powerful ecological scaffolds, dictating where life can flourish and how quickly succession proceeds. This isn't simply wild. It is an anthropogenic wilderness, governed by human-design constraints. Conservation efforts must grapple with this ambiguity. Are we preserving a natural climax community, or are we merely managing the slow entropy of built materials? Experts caution that intervention itself changes the outcome, sometimes stabilizing decay and other times accelerating structural failure. The balance between preservation and letting go remains one of the most profound scientific challenges of our time. Consider the root systems exploiting utility conduits, or the specialized fungi breaking down treated lumber. These micro-ecosystems reveal a complex negotiation, life adapting to human detritus. Understanding this managed decay is key to developing conservation strategies that respect both ecological resilience and structural reality. The sheer vitality of these abandoned spaces forces us into an ethical quandary. Do we treat them as scientific laboratories, preserving the intricate processes of natural reclamation, or do we view them merely as untapped real estate, awaiting the predictable march of human progress? The legal frameworks governing such sites are often inadequate, caught between historical preservation mandates and modern economic development interests. This tension is palpable in local zoning laws, where a derelict factory might hold both protected architectural status and prime commercial value simultaneously. Advocates for ecological preservation argue that intervention, even benign cleanup, disrupts complex trophic cascades, allowing pioneer species to establish self-sustaining ecosystems. They point to the success of rewilding projects globally, demonstrating nature's inherent capacity to heal human scars. Conversely, developers emphasize the economic necessity of revitalization, arguing that inaction leads to decay and blight, diminishing community resources. The challenge, therefore, is not choosing between two extremes but finding a sustainable synthesis, a model where ecological integrity informs rather than impedes thoughtful human reuse. Ultimately, sustainable policy must recognize that nature's value transcends mere commodity pricing. Integrating ecological assessments into urban planning offers a path forward, one where biodiversity becomes an asset guiding responsible human coexistence. The evidence gathered across these forgotten thoroughfares paints a compelling picture of biological tenacity. These abandoned city centers are not merely vacant spaces. They are complex, self-regulating ecosystems and transition living laboratories demonstrating nature's powerful capacity for reclamation. What we observe is a process of rewilding, where the inherent ecological logic of the region reasserts itself, regardless of human abandonment. The flora and fauna here operate under their own rules, creating novel food webs and structural habitats that are entirely independent of our former urban designs. These sites offer vital lessons in resilience. They show us how quickly life can colonize and stabilize a disrupted environment. They challenge the notion that human development is always superior to natural processes. Instead, they suggest a powerful synergy, a model where ecological integrity dictates the terms of coexistence. By studying these forgotten cores, we gain invaluable insights into building cities that are not merely asterisk built upon asterisk nature, but truly asterisk with asterisk it. From crumbling facades to thriving root systems, these zones prove that nature's blueprint is enduring. They teach us a profound lesson. True urban sustainability lies in acknowledging and integrating this powerful, persistent ecological rhythm.